over to the second part of this webinar, which is around the use of the AIS data from the perspective of the hackathon, which was recently held, organized by my colleagues under the UN Global Working Group of Big Data, specifically the task team working on this AIS data. There was a hackathon was done very early in September. We had 17 teams working on with the AIS data, which we have on the UN Global Platform. So it was these 17 teams were got 3 days to work with those data to come up with some innovative solutions in relation to climate actions and SDGs, if possible. We out of those teams, we finally selected the number 1 and 2, which will make a presentation here. And the team that won this hackathon is called Blue Carbon. It's a team led by Thomas de Wilde, who I will give the word to very soon. The team otherwise has Denis Grabash, Tomi Kalava, Alexandra Kapustina, Gennady Abrastov, and Farid Rakhmatulin. So a very international team. I think they're mostly in the Nordic countries. The more further description of the team is available on our website. Please go ahead there. What the Blue Carbon team wanted to do is develop a model for attributing vessel CO2 emissions to locations where they occurred, based on the vessel AIS locations. And they made an interactive application for that. And I will now give the word to Thomas to further introduce and show what solutions they come up with. Thomas, the floor is to you.
Hello, and thank you, Ronald. Much appreciated. Indeed, my name is Thomas de Wilde, and together with, as Ronald mentioned, Denis Grabash, Tomi Kalava, Alexandra Kapustina, Gennady Opratsov, and Farid Rakhmatulin, we are Blue Carbon. And thank you for having us. Now, when we're talking about data innovation and data science, it's almost become a platitude in a way, saying, oh, big data, you know, so much value to be had there. And of course, we would agree with that, but we prefer to show you what you can do with data instead of just talking about it. And just 2 notes that I'd like to kind of highlight as well is that when we saw the opportunity of competing in this United Nations AIS hackathon, we immediately jumped at it because it really goes to the core of what we do, not only in our daily work, but also what the company stands for. Wärtsilä, as its purpose, has to enable sustainable societies with smart technology. And so without further ado, let's demonstrate exactly what we came up with and how we use big data and create digestible information. When first arriving on the platform, we're presented with a global view of shipping emissions. In the top left-hand side corner, we have those emissions broken down further. And when we highlight specific tiles, in the top right-hand side corner, respective emission data is displayed there. Now, at this level of zoom, we can see that there are some interesting areas around the world with high emissions. But what if we're interested in something more specific? Well, we can zoom in, press refresh, and now these tiles have been broken down into their granular versions, allowing us to pinpoint where the emissions are, as well as identify shipping lanes and busy ports. Now, as a researcher, you might be interested in the interaction between emissions, and more specifically, you might be recording local emissions from biogenic or land sources and wanting to subtract the global shipping emission data, the background noise generated by shipping. So if we take the Azores as an example and we go there on the map, we can actually upload a GeoJSON file, allowing us to draw a polygon or a certain shape around this area, allowing us to quickly identify tiles that intersect with this area in order for us to then subtract this global shipping emission data from whatever local recordings we might be making. Additionally, we've also added the exclusive economic zones. And if we were to, for instance, take the Italian one, it'll automatically take us to that location on the map, as well as generate the granular tiles of emission data. Right, so that's what we created for the hackathon. Now, big data or visualizing data is one piece, right? So you create data and then you need to create a front end to show it. But a front end is nothing without data, and a data is nothing without being able to visualize it. So in order to show you how we exactly achieved that, I'd like to introduce Farid Rahmatulin, our front end developer, who will tell us a little bit more about how he created the front end of our platform.
Yeah, thank you, Thomas. Hello to everyone. So a rough mockup had been created by the team, which was up to me to create. So this is what I did. First step was to choose the stack. I stopped at classical HTML, Bulma framework for CSS, and Leaflet JavaScript framework for interaction with the map. The main challenge was to show aggregated data on the global map relatively fast. To achieve that, two methods was implemented. First is caching heavy requests on the backend that allowed to load global map and the most popular exclusive relatively quickly. Second is using different granularity of data, meaning that on the different zoom level, different tile size is selected. So in the future, we are planning to keep working on responsiveness of the front-end page and finalize the API to make it public available. And so now I'm giving the floor to Denis Grebash to talk about data architecture.
Yes, thank you, Farid. So we had three ingredients to our solution, and the first one is this AIS vessel location data. And just for those of you who are not deeply familiar with it, so just assuming looking at the 70,000 largest ships of the world merchant fleet, and if they are transmitting a new position every 5 minutes, then that amounts to 20 million records per day or 7.5 billion records a year. So that's truly big data. But big data on its own is nothing. You combine it, you need to give it some context. And there we were happy to see from the EMSA, the European Maritime Safety Agency, the MRV data. MRV is for monitoring, reporting, and verification. And essentially, since 2018, all the ships that are moving around in European waters, they have to report their yearly emissions, and that covers around 10,000 vessels. So that was our baseline for the emissions data set. Further, we used marine regions for the so-called sea borders of the countries, these exclusive economic zones, and all of that you've just seen being used there in the map. The output of our solution is, on the one hand, the data itself, so that's emissions per area and per day, and that can be distributed in a CSV file or by API. And Alexandra and Gennady will show some interesting stuff later. But then on the other hand, we have the map there, and that's much more than approachable for all the rest. So big data, to make big data actionable, you actually need to make it small. And to do that, we divided the world in a million tiles. You see 5 of them, and you see one vessel there moving back and forth between Finland and Estonia. And in this example, we then reduced the data set from 270 records to 5, so that's 2% of it. And with that running on the UN Global Data Platform, we're able to aggregate a day of AIS data in 40 minutes. And now I hand over to Tommi Kalava, our data science architect from Finland, and he will tell a bit more about how it was done.
Okay, thank you, Dennis. So how we are estimating the emissions? We combined last year's emissions reported by MRV to AIS data. For about 10,000 vessels, we took features that would have some explanatory power to the emissions, such as speed, draft, and vessel dimensions, and aggregated those to the same yearly level that we have in emission dataset. Then we fitted a random forest regression model to that data. With the model and tile vessel aggregations that Dennis mentioned, we are able to calculate the emissions for each of these areas for each day. And I'd say this is quite handy approach, but it comes with its limitations. First of all, we notice that the estimations for individual vessels are usually not super accurate. However, over a bigger number of vessels, it performs quite well. And for our case, that is fine, since we are looking more at areas with a lot of vessels and their combined emissions. But the problem occurs in areas where the training data doesn't quite match with the AI's records. For example, if an area is smaller vessels, it might not give accurate results, since we don't have small vessels in the training data, as seen from this distribution of vessel lengths. And also for the vessels that are staying still, the emissions are typically overestimated. But both of these limitations we face in port areas and rivers mainly. And at this point, we address these limitations with certain simple rules and assumptions in the process. For example, assuming that ships that are not moving are not producing emissions. And there are of course still room for improvement in many fronts, and also factors we didn't have time to address at all yet, like accelerations of vessels. And finally, when we talk about validating the performance, typical way of measuring the performance of a machine learning model was not enough in this case for various reasons. And that's why Alexandra Kapustina, also a data scientist, made some additional validation there.
Yes, thank you, Tommy. Indeed, we wanted to have some independent model, and we went to IMO, Greenhouse Gases official report, official study, and got a physical model of emissions. And based on AIS data, and we used some average characteristics per ship type and size, we used this model to validate our model. Of course, using particular characteristics of ships would give us more accuracy, but still it was like a comparison. Also, we tracked the approaches IMO organization used to allocate emissions before. Firstly, started from vessel-based when they tracked emissions by vessels, when they switched to voyage-based, taking into account ports of departure and arrival. And here our special-based approach could be seen like a next step, like an extension of these methodologies. Also, we wanted to give an example of local usage of our tool. We used an area around Rotterdam port, and using our tool, we calculated the special distribution of emissions and also some coefficients like emissions per distance. Ship travels in this style, and we wanted to show how comparing with coefficients and values, we could maybe spot some places which needed to be investigated for maybe further traffic optimization or some policies to be used. And also we could analyze it and get some port emissions. And Gennady Obraztsov, my colleague, could add us more information, a data scientist.
Thank you, Alexandra. First, I help Alexandra calculate the other emissions, sulfur and nitrogen oxides. Why these emissions selected? NOx has a high biological activity and leads to a decrease in respiratory function, and SO2 affects the rate of photosynthesis, especially in conifers. I found data on the concentration of nitrogen and sulfur oxides. On the slide, you can see mass concentration of nitrogen in Rotterdam area. This data is freely available on Copernicus site. So then I visualized our model's results in Rotterdam area to check it qualitative. Copernicus data is on the left picture and our model's result on the right. I overlaid the average wind speed to check that the distribution of nitrogen oxide concentration was not influenced by land sources. So in the future, with more resources, we could do a diffusion analysis, also calculate perixical nitrites and aerosols, and maybe overlay air quality data in coastal cities, especially in emission control areas, and overlay wind data on the map. Yeah.
Thank you, Gennady. And that's now brought us to the end of our presentation. Before I open it up to questions and answers, I did want to specifically thank the United Nations, the Working Group, Global Data Platform, everyone involved in hosting this competition. You know, it was great for us, honestly, to be able to compete against such esteemed research institutions and groups who clearly have great competence in this area. We like to think as Wärtsilä that we have some of those competencies in house as well. So it was nice to be able to showcase that, but it's also nice to actually address kind of the elephant in the room. And that is emissions, right, and their impact on climate change. We chose, because that was one of the two options to choose from in the competition, the Sustainable Development Goal of climate change. And we want to lead that discussion. We want to increase transparency. We want to increase availability of data related to emissions so that you can actually have an informed decision about it, or an informed discussion. And we wouldn't want to stop there either, because we believe there's a bigger picture here, right? It's not only the difference between man-made and biogenic emissions, but also then looking at land-based emissions, or, you know, shipping emissions like we have here. And so putting that all together in one complete holistic overview, it is our belief that that would not only increase transparency, but also allow policy making and decision making with a, you know, a clear-headed view on the facts. So we look forward to this data being made available, whether it's on the United Nations platform or on a Wärtsilä platform. We hope that some of you perhaps might even be interested in seeing the kind of the platform or its data that sits behind it. That's only going to strengthen the point of making this available to researchers and policymakers. So thanks again for your attention. And if you do have any questions, please shoot now.
Thank you, Thomas. Yes, this is a really impressive presentation from your whole team, all of them involved in this short period of time of the hackathon. It was truly impressive what you have achieved. Also like it that you added in a number of additional data sources to mix it up with the AIS data to get more results. I think that was truly great. Also, that's also, of course, that you won this hackathon. It really, you really made that point very clear why you were chosen in this. Yes. I will open it up for discussion. I want to first of all also on the last point, we certainly would like to. And I can tell you that work with your team further on this going forward. I hope that this is the start of things. And also very happy to see that the global platform was being used for this and show that this is a kind of a collaborative environment where we can produce a very good results in data innovation. I open the floor here. Would like to see maybe a show of hands for those who want to pose a question on this presentation. Because I see a question in the chat. Yeah, I have some.
Thank you, Max. I do see some. Yes, Gabriel is raising his hand. Gabriel, okay, if you want.
Yeah.
Absolutely. Thank you, Thomas, for such a great presentation. Once again, congratulations on having the first prize. Certainly, you do have like a very detailed project, and we're very glad that we got the chance to see your details. Going into specifics, you guys have like a granular tile description. Just as a reference, what's the size of that tile in terms of arc seconds? You got that information with you?
Yes, well, actually, it's not in arc seconds, so the mileage varies, right? Depending right, on where in the world. But Dennis perhaps can give us a bit more information about what the typical tile size is for the various zoom levels. And you're muted, Dennis, in case you'd be talking.
Thank you. Yes. Beginner's mistake. Yeah. So it's actually related to the Google Maps or OpenStreetMap zoom levels. We chose zoom level 10, so that's 1,000,000 tiles. And depending on the size, it's I think if I recall correctly, like around Singapore, so around the equator, it's 40 kilometers the side of one of these squares, and then in the Baltic Sea, it's around 20 kilometers. So we try to keep the standards there, what are used by these popular mapping platforms for further compatibility.
Thank you.
Thank you.
Any further question, Ivo?
Yes, let me also congratulate the team. It's really very nice to see how this has come together in such a short period. So congratulations with that, the team from Wärtsilä. What I was thinking, maybe Ronald, also in the way forward on this, as we develop dashboards on this at the UN web environment, is this information that we could release experimentally on dashboards for the world to actually start using? I don't know how far it is, but would there be a possibility to work in the next step to make this more sort of permanently available and a fixture of our new dashboards that we're trying to shape? And that's a question to probably Thomas, whether that would be something that you would be like to think about with your team going forward.
Yeah, thank you for the question and your kind remark as well, Ivo. And I will actually add on to your question, Andrea's question in chat about the time period covered by our analysis. And that is, yes, indeed, we want to make this data available. We would actually like to go one step further, because for the hackathon, as Ronald mentioned, we only had a few days. We had to use a confined data set, right, of only covering about a week's worth of AIS data. So what we would like to do is we would like to improve the solution further to ingest data on a daily basis, so that it's a live, self-updating, real-time type of platform, and then have it somewhere hosted indeed for anyone to use at any given time, both from a visual point of view, but also from a data export point of view, to get the underlying data.
Thank you.
Yeah, thanks, Thomas. Can I add on? Can I add on to this just to on the point, like how much support do you get internally from Wärtsilä to work on this more with in collaboration sector?
Well, it's a great question, and Marky in chat also asks about how do we know each other. So we're colleagues, and our passion for everything data is the reason why we know each other, and then of course we have worked collaboratively in the past on various internal projects. I will say that our participation in the hackathon was really us just coming together. Let's go for it, and we made sure that we checked it with the powers that be, that we wouldn't upset anyone. But it was very much kind of an employee-driven project, and it's, to be honest, one of the great things of working for Wärtsilä. There's plenty of room for innovation, and you can get the necessary support or buy-in to do these type of things. Now, of course, the next step is, how do we formalize this effort? How do we make it more of a, nice, well formally kind of organized collaboration between Wärtsilä and United Nations, opposed to just a bunch of employees taking part in a hackathon. I guess that's the small challenge. I see there's perhaps another raised hand, or
I did not see a hand. Is there a hand?
Esperanza, perhaps.
Esperanza. Okay. Yeah. Yes, please go ahead, Esperanza.
Yes, thank you very much. This is really indeed a very excellent presentation and work that you've done. I have two questions basically. One is on the model that you were presenting. I think the lady that presented said that, in terms of the model validation, you have to find an alternative one, because the one that you got is not necessarily the one that you wanted to have in the model. So my question is, in terms of identifying the best model, what was the criteria, and then related to the criteria of the hackathon, was it used to identify the winner? I mean, the model validation itself. And so the second question is related to the way forward of this output or this outcome of this hackathon. Because at some point, I think somebody already also mentioned about, how this data could be linked to something more like, I would say, timely. And in terms of, using this data for, like, for example, addressing SDG related issues, so that a more timely data could be used for outputs, and like countries or whoever could benefit from these outcomes can easily see the data. So for example, you're using Spark. If you have Spark streaming, could be linked to this with the original data set, or whoever is owning the data set, if this is, nothing sensitive related to that.
Yeah, thank you for the questions. I'll park the one related to, did we win thanks to our, the way that we validated our model, to our dear friends from the jury, I guess, that are present here. And I'll touch on your future question first, then pass it on to Alexandra and Tommy to talk about the model. And I see there's another question in chat as well related to models. So maybe Alexandra, Tommy, you can already kind of, gather your thoughts about that one. In terms of the future, you're absolutely right, and the Spark platform as well, to be able to, like we said, do the improvement that it ingests data automatically on a daily basis. Dennis was talking about that this would only really take about 40 minutes. So, it could be a scheduled job somewhere during the night, would keep this solution current. And because it's holistic, because it's global, you do bypass some of the issues that you otherwise see with locally recorded emissions, for instance, right? Because there's quite a bit of difference between from country-specific measurements. But again, yeah, we're happy to have it there, but I guess the UN and maybe the powers that be in Wärtsilä need to kind of pull the trigger. But we're definitely pushing to see that be a reality. Now, Alexandra, do you want to talk about the model validation and then maybe pass it to Tommy about the actual model?
Yeah, I could add maybe some details, because our model for validation, IMO, based on IMO methodology, is not so, how to say, doesn't perform for all types of vessels. It's just for some typical more popular types, and we used average characteristics there because we didn't know particular like fuel type or something like this. It could improve it, and so we checked it for the most typical types like cargo ships and so on. And our ML model was validated on this cases, and we used it for all other vessels because it's more universal. Maybe Tommy will add something.
Yeah, okay, thanks. So the algorithm which we used was random forest regression, and that was like the first out of the pocket. We didn't spend that much time testing different algorithms because we had so much stuff to do also in the data flows and pipelines and the other backend work also there. And how does it work is that it kind of model gives us the estimation what the yearly emissions would be if the vessel would have those parameters that we get from the AIS record. And those are like the model expects like average speeds and stuff like that. So it doesn't perform well in low speeds or very high speeds or when vessel is accelerating. And also the the vessels in the training data are bigger vessels. So that kind of limitations we have, and we have to validate with different methods then that we are producing somewhat right results. So there's definitely room for improvement in the accuracy, but also we have ideas how to do that.
Yeah, and on that note, you know, we have a lot of internal data, of course, as an engine supplier, but we chose not to use any internal data because, you know, in the spirit of the competition, we only wanted to use publicly available data. As much as the temptation was large to double check, you know, with our internal data whether our emission estimations were correct, but you know, that's just, we wanted to play it, you know, fair play. So with the improvements that we have in mind, maybe that could be an opportunity as well in terms of improving the model with measurements that we as a company make. Now, I don't want to take too much time away from the next team. I see that we have two more questions. Perhaps let's just quickly do those two and then wrap it up. Gabriel Gomez, if you want to ask your question.
Hi, thank you very much. Actually, it's not so much a question, it's more a kind of general comment. I wanted to mention that this hackathon was actually financed through a development account, so a capacity building program of the United Nations. And I remember the first time when Marky and Jonathan came to me and we came up with an maybe using a little bit of the money for a hackathon. People around here thought that we were a bit crazy. But just to reassure you, and I liked very much when you said we speak a lot about big data. Now let's try to do something with that. I think that this is an excellent example, very much a success story of this development account, this hackathon. And in the next development account that we're preparing at the moment, drafting the concept note, we explicitly mention that we will keep money on the side for a few hackathons. So we will continue to work with that also in the future. And I wanted, of course, to congratulate all my colleagues, also the winners, but also all the other ones that participated in this hackathon. I think it's really something that is fantastic, and I will use that to illustrate, I mean, this success as a success stories of this development account. Thank you very much, everybody.
Couldn't agree more, Gabriel. Thank you. Christophe, last but not least.
Yes, I will be very, very short. I have just one question, and it is also a remark about the training data set. Because the question could be, and you won't probably have time to answer, the trade-off between having a more detailed training data set where you have also the sea, the weather forecast, the wind, or whatever, or a more accurate, more maybe costly model. And in fact, the remark is that I believe that the next gold mine is not in the big data themselves, but in validated training data sets. Because with very good, accurate training data set, even simple model could perform very well. So the remark is, should we build a sort of Fort Knox of training data set that are really, really with very good data? Of course, it's just an idea.
I'm sure that Tommy and Alexandra and our other data scientists in the call here would jump the opportunity, Christophe. Absolutely. Thank you.